Transformations Review, Lessons 17 through 21. I'm going to be walking you through every problem in different videos. I have everything already written down, so it's all just covered up. So what I'm going to do is I'm going to explain things. When I'm done explaining, I'll say, pause your video and write it down. That's when you should try to write stuff down. Don't try to write stuff down while I'm talking. I will talk too fast and you won't be able to get it all. So wait till I say pause the video, and when I do that, that's when you can get everything written down. Okay? So here's question number 1. What sequence of transformations can be used to show that triangle PQR is similar to triangle P double prime, Q double prime, R double prime? Well, when you look at the two triangles, they're clearly different sizes, and if they're clearly different sizes, we know there has to be a dilation. And we learned in lesson 21, if you have a dilation, then you want to work backwards to find your answer. The easiest way to do the problem is to work backwards. So we're going to start with step 1, which is finding the scale factor. I find the scale factor by taking a side length from the image and dividing it by a corresponding side length of the pre-image. So the side length I'm going to use from my image is P double prime, R double prime, and that length is 16 units. Then I'm going to use its corresponding side length on the triangle PQR, which is PR. That is 4 units. So the scale factor would be 16 divided by 4. And 16 divided by 4 is 4. So my scale factor is 4. Okay, take a moment, get everything written down that I just did. Pause your video and do so now. Okay, step 2 is to find triangle P prime, Q prime, R prime. And again, we are working backwards. Normally, you're given the pre-image and the scale factor, and we took pre-image times scale factor to find the image. But because we're working backwards, we want to find the pre-image by taking image divided by scale factor. So my image is P double prime, Q double prime, R double prime. I'm going to take each one of those coordinates, and I'm going to divide by 4, my scale factor. So that would look like 8 divided by 4, negative 8 divided by 4 for P prime. Q prime would be 0 divided by 4, 8 divided by 4. R prime would be negative 8 divided by 4, negative 8 divided by 4. Again, wait till I tell you to pause the video to get all this written down. So if I take each one of those coordinates and I divide by 4, I find P prime, Q prime, R prime, which is P prime is 2, negative 2, Q prime is 0, 2, and R prime is negative 2, negative 2. Now pause your video and get all of step 2 written down. Okay, step 3 is to graph P prime, Q prime, R prime. So I go back over to my graph here. P prime is at 2, negative 2. So I go to the right 2 and then down 2. That's P prime. Q prime is at 0, 2. 0 for the x coordinate means I don't move left or right. I just need to go up 2. That would be Q prime. Negative 2 means I go to the left 2 and then down 2. That would be R prime. Now I'm going to take and connect the 3 points. Just making sure my points are where they should be. And then I'm going to make it a little bit thicker. So there is P prime, Q prime, R prime. All right, take a moment, pause your video, and do step 3. Step 4 is to look at the orientation of P prime, Q prime, R prime, and PQR. If I look at these, Q and Q prime are across from one another. So you might start to think it's a reflection. However, since P and P prime are not across from one another, and R prime are not across from one another, it's not a reflection. So this is not a reflection. It has to be a rotation. So I'm going to go down here to step 4, and I know I have a rotation. So it's a different orientation, and I'm going to examine P, which is at negative 2, 2, and P prime, which is at 2, negative 2. Well, if it were 90 degrees clockwise or 90 degrees counterclockwise, 270 clockwise, 270 counterclockwise, if it was any one of those, the numbers would get flipped around. Well, it's hard to tell that here because everything is at 2. All right, these don't get flipped around, and these don't get flipped around. all right? If they did, they would be the exact same thing, and we don't have a rotation where it's yx. So instead, we're going to look at x to x and y to y. If we do that, look, it went from -2 to +2, and it went from 2 to -2. So that means it was the opposite of each. It was the opposite of the x coordinate and opposite of the y coordinate. Opposite of the x, opposite of y. And if it's opposite of x, opposite of y, I look at my transformations, or my rotations chart here. I've got opposite of x, opposite of y here, opposite of x, opposite of y there. If you look above that, that's 180 degrees clockwise or counterclockwise. So that means my triangle rotated 180 degrees clockwise and counterclockwise. Okay, that's step 4. Pause your video, get all of that written down. Step 5 is our final answer. That's where we take everything and we put it together. So we know we had a rotation and a dilation. We had a rotation and we had a dilation. So our final answer is the sequence of transformations included 180 degrees clockwise/counterclockwise rotation about the origin, followed by a dilation with a scale factor of 4. Again, the sequence of transformations included 180 degrees clockwise/counterclockwise rotation about the origin, followed by a dilation with a scale factor of 4. Pause your video, get all of that written down. Okay, so that concludes question number 1. Please take a moment, pause the video, make sure everything that I have written down is written down on your paper. Please don't forget anything. We don't want you to miss any points for skipping parts of the problem. If you have any questions on number 1, please let me know.